des décollages. Fantastische Blue Amerika.
For billions of years, the matter which later formed our galaxy, like countless others, existed in pitch blackness. Black is still the dominating component of our universe, which is made up of 75% dark energy, 21% dark matter, with black holes representing an unknown small percentage, and stars, which produce the light in our universe, but make up only 0.5% of its total energy density. So the dark side is the key component of our universe. To mark this year of astronomy, 3 European specialists shed some light on the matter.
2009 is the year of astronomy, and we want to teach the public during this year and inform them about this dark side of the universe, which represents some of the deepest and most interesting puzzles of modern physics.
Of the 3 components which make up the dark side, black holes have had the most publicity and have fascinated scientists and science fiction writers for a long time. These are formed when stars die or explode and transform into supernovas, giving birth to black holes. Dark matter, which was unheard of until the 1930s, is next on the list. Observation of dark matter isn't easy as it doesn't emit light, but scientists know of its presence because of the effect it has on the gravitational pull of the objects around it.
Suppose that you were to look at a dance floor in a dark hall, and you have ladies in white, and you have all the men in black. And you don't see the men because it's dark. And you see those ladies dancing around something, and you don't know what it is because you can't see it.
The third component of the dark side is dark energy, and this is perhaps the deepest mystery of all.
After the Big Bang, the universe expanded greatly, and the gravity of all the materials slowed down the expansion of the universe. But then 5 billion years ago, very suddenly, the universe started accelerating again its expansion. And we think that this is caused by this dark energy field.
But if these phenomena can't be seen, how can they be detected? This huge hall in the Max Planck Institute in Germany is at the heart of the Virgo project, an ambitious international scheme. It aims to simulate the formation of the structure in our universe in images using powerful computers. Feeding these computers is information collected from astronomical satellites and telescopes, both in space and here on Earth. While the dark side isn't directly visible, astronomers can map its position and effect by measuring its impact on the gravitational force of its surroundings. One of the ways this is being done is by using a very large telescope on the other side of the world in the Atacama Desert in Chile.
What we set out to do is to take the nearest object where we suspected a black hole might reside, and that's the center of our Milky Way, and make measurements there with ever better technology, bigger telescopes, new techniques, new detectors over those 20 years, where we were then able to measure the motions of material stars around where we suspected there might be a black hole.
The European Space Agency is also investigating black holes using its own X-ray telescope, XMM Newton, as well as the Hubble telescope in cooperation with NASA. Also, with missions such as Planck that study the residue left over by the Big Bang, scientists hope to further their understanding of the evolution of the universe. It's difficult to imagine something you can't see or an energy you can't feel. However, astronomers believe these abstract concepts are the glue that binds our universe together in an invisible dance between the seen and the unseen.